Hi everyone, today our group is going to do a video presentation regarding to Semenggong Wildlife project. So our project consists of 5 major, which are software development handled by me and Ethan, data science handled by Yexing and Nicholas, AI handled by Brenda, IoT handled by Jordan, and cybersecurity handled by Hongwei. Next, I'm going to start off with software development. My name is Darren. For this software development, I'm focusing on front-end UI/UX design, and Ethan will be presenting more detail on the functionalities on each web design. So this is our home page. Our whole website is designed by React.js because it's more easier to manage. And this is our slider. User can view the images around here. We have the tourist activities like things to do in Semenggong and the wildlife animals in Semenggong and the event happening, currently event happening right now. And we have the real-time progress bar to track user donation amount. And interesting about this website is that we embedded a called Chopper bot. We have text that user can ask the question like FAQ, like what is the time opening in Semenggong, and we have the call upload image and print video. It is used to for user to upload photo if they are not very sure about what kind of animal it is. You can just upload the photo and or a video, then it will predict the result. So for the other page, we have the discover page, the wildlife page, events page, and donation page. And this is our register page, and this is our login page. So every time user login or register, they have to go through an OTP. So after user successful login, for example, if admin login, they can see the user data, they can view the Tableau dashboard, interact with it. And lastly is the IoT dashboard where all the data, sensor data is stored here. Next is the member page. This is a recommendation tool where it will track user activity based on the recent click. User also will be gifted vouchers such as new user voucher and quiz, where if you attempt the quiz in the events, then you will be gifted a 10% voucher. User also can interact with the profile by building their own profile, such as clicking the mail and your birth date, and save it, then your profile will be set up. So next, this is our UI/UX design for mobile application. We have Discover. You can see orangutan feeding session, things to do in Semenggong, and wildlife in Semenggong, events happening like wildlife quizzes, orangutan rehabilitation program, and a donation page. So you can just click into each information, like click into this to see the information. And for wildlife, you can click in it and it will show the wildlife information. And this is a real-time donation bar for every user, where it will collect the amount from all user. And here is the map. You can click on it and see the location, where is the place in the Semenggong. And one of the special things in this app is that we have a translation tool. We have English, Chinese, and BM. So this one is Chinese, everything will be translated to Chinese. And we have BM, and everything will be translated to BM. So that's it for mobile application. The rest will be presented by Ethan because it's more technical stuff and he handle backend.
Thank you, Darren. Hi everyone, I'm Ethan. In this presentation, I will walk you through the backend code of our project, which is built with Node.js and MySQL. To get started, the backend establishes a connection with a MySQL database using the MySQL package. It also ensures that the database and necessary tables are created when the application is initialized. Here is an example of the database and the tables we have created. Once the database is set up, the backend makes sure there is always an admin user. If not admin is found, it automatically creates one with predefined credentials. This admin user is crucial for managing core settings and operations throughout the app and website. Now, let's talk about one of the main features, user management. Here's the route that handles user registration. It ensures that the input is validated before storing the new user information in the database. This part of the code verifies user credentials by checking the database for a match and grants access if everything is correct. For the admin, we have integrated an admin dashboard. This dashboard includes APIs that allow actions such as viewing, adding, and editing user details. providing full control over user management for efficient administration. On the user side, we have implemented a user profile feature where users can update their avatar, date of birth, and gender, allowing for a personalized and customizable experience. One of the standout features of our backend is the user preferences management system. This feature tracks the activities users are most interested in and uses that data to offer personalized recommendations. When a user clicks on an activity to read more, an HTTP request is sent to the backend, and their preference for that activity increases by 1 in the database. When the user logs in, the frontend sends a request to the backend, which returns the preference counts for all activities. The system identifies the activity with the highest count and displays a recommendation to the user via a pop-up on the app or website. Next, we have the donation system, which allows users to contribute to wildlife conservation efforts. To ensure the integrity of donations, users are required to log in before making a donation. Each time a donation is made, the backend receives the donation amount and records it in the donation table. The homepage of the app or website includes a dynamic donation bar that updates in real time, reflecting the total sum of donations made by all users. Lastly, the voucher system is designed to reward user engagement. When a new user registers, they automatically receive their first voucher. These vouchers can be redeemed at the souvenir shop, where staff can verify and click the redeem button to mark it as used. Once redeemed, the backend updates the voucher status, ensuring that used vouchers no longer appear or can be reused. That's all from me. Thank you for your attention. Now I will hand it over to Brenda, who will walk you through the AI aspect of our project.
Hello, my name is Brenda, and now I'll be talking about the AI core of our solution. The first feature we implemented is a two-stage species detection and classification model using YOLO V8 and ResNet. So our workflow begins with a thorough data preparation to ensure that a high-quality dataset is used for training. We clean the dataset by mapping similar species, correcting incorrectly placed images, and we ensured all species were represented. To address the underrepresented classes, we apply augmentation techniques to balance the dataset, and finally we will pre-process the dataset to increase its size. Next, YOLO V8 was used for species detection, so input images were resized to 800 times 800, and YOLO V8 was trained for 25 epochs with a batch size of 16 and a learning rate of 0.01. After training, the model detects species and crops the relevant regions, passing them to ResNet 50 for classification after resizing to 224 times 224. ResNet was trained for 10 epochs with a learning rate of 0.0001, so both models were then deployed to detect and classify species and camera trap images, which completes the two-stage process. For model evaluation, YOLO V8 achieved 66% precision with 60% recall and a mean average precision for IOU 50 of 68%. It struggled with fine localization, particularly for rare species like slow loris, and the ResNet model, whereas for ResNet, it achieved a 79% accuracy, precision, and recall, and a 76% F1 score. And for ResNet, similar to YOLO V8, it performed better on more common species. The final model were implemented to run predictions on camera track images, and the results will be stored in our database for visualization purposes. Additionally, the trained model is also integrated inside our website, so users they can upload images to run predictions on. Users can also run predictions on videos as seen as demonstrated here. Now let's talk about our second features, which are knowledge-based chatbots. Starting with first we established a connection to the database using MySQL connector library, and we define functions to fetch related records, such as site information based on species or image ID. For temperature trends, we retrieve average, highest, and lowest temperatures for each site. After retrieving the data, we generate text descriptions of the retrieved data, and these descriptions are then embedded using sentence transformer model and stored in a Facebook AI similarity search index for fast retrieval. So when a user asks a question, the input is encoded into an embedding, and we will search for the most similar records from the Facebook AI similarity search index, and the chatbot will return the most relevant information. So here's a demonstration of first chat chatbot where I'm asking a question about species distribution in a specific site. Past conversation can also be accessed at the site panel. Moving on to Chopper, we prepared the data by processing the JSON content from our website, generating embeddings with using sentence transformers and storing them in a Facebook AI similarity search index, which allows for fast and efficient retrieval of information. So similar to FirstJA, when a visitor submits a question, the chatbot will encode the query into an embedding and searches the most similar content using the Facebook AI similarity search index, and this results will be returned by our chatbot. Here's the demonstration for Chopper chatbots. So you can ask questions about Simangowala Center or about SFC, for example. And just like FirstJA, the past conversation histories can be accessed at the side panel.
Thank you, Brenda. There are four key areas in the cybersecurity part, which is role-based access control, RBAC, multi-factor authentication, MFA, data encryption and integrity, auditing, and backup and data recovery. We start with role-based access control, where each user is assigned a role that determines their access level. These roles are stored in the database. For instance, admin users have higher privilege, while default users are assigned to role of user. This ensures that access to sensitive resources is limited based on a user's role, reducing the risk of unauthorized action and enhancing overall system security. Next is multi-factor authentication, which adds a crucial layer of protection when a user logs in. They provide their credential and an OTP is sent to their registered email. This OTP must be entered to complete the process. By requiring both something the user knows, like their password, and something they have, like access to their email, MFA ensures that even if credentials are stolen, unauthorized access is prevented. Data security is further strengthened through data encryption and integrity auditing. Passwords are hashed using cryptography algorithms before they are stored in the database, making them unreadable even if the database is compromised. As you can see in the database table, only hash values are stored, ensuring confidentiality and aligned with best practice for safeguarding sensitive user information. Finally, we implement robust backup and data recovery process. Our system saves all data from the database to a JSON file named backup.json every 30 seconds. This ensures that even in the event of system failure or data loss, we can quickly restore operation with minimal downtime. The backup contains critical information such as user role and credentials, providing a reliable way to recover the system. By combining this mechanism, RBAC, MFA, encryption, and regular backups, we create a secure and resilient system that protects users' data and maintain operational integrity. That's all from me. Next, Yue Xing will continue the presentations.
Thank you, Hongwei. Hello, everyone. My name is Liu Singh, and I'll be taking you through how we use data science in wildlife conservation. This first slide has an interactive burner map showing key sites details such as forest type, canopy height, longitude, latitude, and water occurrences. What's useful is the ability to filter and explore. User can choose the region or country they are interested in through a drop-down menu. There's also another drop-down menu feature for selecting specific forest types, allowing us to focus on particular ecosystems and their unique characteristics. This map provides a clear and customizable way to visualize and explore the habitat conditions of wildlife across Borneo. Next, on these slides, we are looking at species distribution across Borneo's wildlife sites. For each site, we show the total number of species present and include images of the animal to give a better idea of the biodiversity at each location. This helps users easily understand how many species are found across different sites, providing an overview of the wildlife diversity in Borneo. On the following slide, we explore species detection trends over time. Here, we track the total number of species detected throughout the year broken down by month. This helps us to identify seasonal patterns and how species behaviors change over time. What's more, we can filter by daytime or nighttime activity so we can see how many species are active at different times of day. Additionally, we have a feature to select specific species and track their activity patterns. Finally, this slide shows how canopy height and forest cover influence species counts. The top graph highlights the impact of canopy heights while the bottom focuses on forest cover. Users can adjust filters to explore specific range, making it easy to spot patterns such as higher biodiversity in areas with dense forest cover or high canopies. Now, I will hand you over to Nicholas, who will explain in the other part of data science. Thank you.
Thank you, Yue-Xing. My name is Nicholas. To begin this project, we focus on cleaning the dataset provided. Initially, it contained 20,000 images, including numerous duplicates. Through data cleaning, we identified and removed duplicate entries, narrowing it down to 56 unique and relevant images. These refined images were then prepared for use in the real-time dashboard, ensuring clarity and precision in the visualizations. In the next step, we develop a real-time data visualization dashboard by integrating Google Sheets with Tableau. This allows for dynamic updates where changes in the source data, such as modifying species name or counts, are reflected in Tableau. While updates are not instant, refreshing the connection ensures that the dashboard always displays the most accurate and current data. For species distribution modeling, we utilize machine learning techniques, specifically random forest and gradient boosting models. These models were combined to form an ensemble that achieved an accuracy of 86.2% and an AUC score of 92.2%, demonstrating high predictive performance. The ROC curve illustrates this performance, while the script output shows how the model predicts species presence with probabilities. Additionally, users can input environmental data to obtain real-time predictions, enabling dynamic and actionable insights. Now, I will hand the mic over to Jordan, who will continue with the IoT section.
Hello, everybody. My name is Jordan, and I am going to present the Internet of Things part. So I create a posture detect system using ESP32 microcontrollers, connects with GIR sensor, sound sensor, and a button as the pressure track. So this system has a automatic data transmission. It sends data to the database only when motion is detected and the track is triggered. Then it will send an email alert when the motion is detected. And now I'm going to demonstrate how it works. So first step is to connect the ESP32 to the computer. This shows is because the database is not created yet. So now I'm going to create the database. To create the database, we need to start the Apache and the MySQL module. Then we go back to the VS Code and create the database by entering node, following by the file name. So we go to the localhost my PHP admin, and we have seen the database is successfully created, but it is empty now because the motion is not detected and the trap is not triggered. Go back to the Arduino IDE to show if the motion is detected or trap is triggered. So we press the button to pretend the trap is triggered. If if the trap is triggered, the data will be sent to the database. And when the motion is detected, the data will also sent to the database and an email alert will be sent. So this is the data that sent to the database just now. And this is the email alert that will be sent when the motion is detected. That's all for my presentation. Thank you.